I'm making this video at exactly 3:15 p.m. and it might get uploaded a bit closer to the 4 o'clock p.m. side rather than the regular 3:30 side that I usually upload my videos, and that's because I had to go to the post office to export my pet kangaroo. Yes, I had to ship it off to its native land, Hurricane Sandy. A kangaroo, baby kangaroo, just plopped on my backyard, and I fed it, and I cared for it, and I growed it to maturity. But now it's too big for my backyard, so I just had to export my kangaroo. So yeah. So now that that's over, might as well do page 455 in the blue textbook. I have done these problems ahead of time, so let's try and do this. Number 14 asks us, graph the quadratic equation, use the integral values for x indicated in parentheses to prepare the necessary value of tables. I'm not going to graph this, you're going to graph this, but what I am going to do is I'm going to give you a value of tables. So let's have an x here, have a whatever you call it here, and let's have a y here. Oh my god, that is the worst line that I've ever drawn. That's only a bit better. So for 14 we have y equals x squared minus 8x plus 7, and then we have y. Interval is from 1 to 7, so 1, 2, 3, 4, 5, 6, and 7. So what do we do here? Just plug in x anywhere you see one, kind of like a function chart. So 1 minus 8 plus 7, it's going to be 0. I have done this table already, so I might save you the pain. Y equals 4 minus 16 plus 7 is 5. Y equals 9 minus 24 plus 7 is negative 8. Y equals 16 minus 36 plus 7, and this is going to be our turning point, negative 13. Y equals 25 minus 40 plus 7 is negative 8 again. And 6 is y equals 36 minus 48 plus 7 is going to be negative 5 again. And lastly, y equals 49 minus 56 plus 7, going to be 0. So that's your tables. So the coordinates that you're going to have to work with is 1, 0, 2, negative 5, 3, negative 8, 4, negative 13, 5, negative 8, 6, negative 5, and 7, 0. So these are the points that you just plot and then connect them using a smooth curve, or the smoothest curve you can come up with. So that's 14. Number 20. Number 20 says, write an equation of the axis of symmetry for the given parabola. So number 20 we have y equals 2x squared plus 3, and the axis of symmetry is x equals negative b over 2a. And in this equation we see that b is 0, right? Because there's no x, there's only a c and an a term. So you can immediately tell that if the top is going to be any form of 0, then it doesn't matter what's on the bottom here. If this is 0, the entire thing is 0. So this is just going to be an x equals 0 axis of symmetry. Let's try a bit harder question. 21. Oh, actually, let's go back to 20 for a second. It's a three-part question. So we know that x equals 0. And this is going to be our axis of symmetry. And B, tell whether the turning point of the parabola is a maximum or minimum point. Well, if the A term is positive or greater than 0, then it's going to have a minimum point. And if A is negative or less than 0, it's going to have a maximum point. If you want to kind of see this, this is a positive graph and it's going to have a minimum. This is a negative graph and it's going to have a maximum. Okay, so is it a maximum or a minimum? Well, we know that the A was positive, right? 2. So if it's over, it's going to be a minimum point. Now find the coordinates of the turning point. Well, if it was 2x squared plus 3 is y, and we know that x equals 0 is one of the points, we can just find the turning point by substituting 0 here, I suppose. So 3 would be y, and if x is 0, the turning point is at 0, 3. And that is a completely solved three-part question. Okay, now let's move on to a more difficult question, number 26. And here it's y equals 1/2 x squared plus 3x minus 1/2. So first we find the axis of symmetry. Negative b over 2 times 1/2. This is going to be the x. So what is this? X equals negative 3 over 1. Because 2 times its reciprocal is 1. That's a property that we learned. X is negative 3. Okay, so if this is the axis of symmetry, and our A term is positive, it's going to have a minimum point. Our vertex is going to be a minimum point. So now all we have to do is substitute negative 3 into this equation to find the actual vertex. Negative 3 squared plus 3 times negative 3 minus 1/2. Y equals 1/2 times 9 over 1 minus 9 minus 1/2. Okay, fractions, fractions, fractions. Let's see what we can do. Well, this can simplify to 9 over 2. And 9 over 2 minus 1 over 2 is 8 over 2. So I guess we can rewrite this to be 8 over 2 minus 9. And what is 9? That's the same thing as writing 18 over 2, right? So 8 over 2 minus 18 over 2 would be negative 10 over 2, and that's just equal to negative 5, so our y coordinate would be negative 5. It's a bit of hairy arithmetic, but it's not overly difficult to work with those fractions. So for x is negative 3 and our y is negative 5, our point's going to be negative 3, negative 5. Cool. I just want to do one of these last questions here. The other questions, 33 and 34, aren't too difficult, but I want to do 36 really quick. And 36 says, if x equals negative 3 is an equation of the axis of the symmetry of the parabola y equals x squared plus bx minus 9, and the axis of symmetry is given as x equals negative 3, then what's the value of b? Even though we still have the equation of the axis of symmetry over here, we know that x is equal to negative 3. We can't just substitute negative 3 in here because there'd be two variables, so a y and a b. So what we have to do is we have to use the axis of symmetry equation still. X equals negative b over 2a. And as you can see, negative 3 is going to be equal to negative b over 2a, right? If x is equal to this and x is equal to that, then this would be also equal to that. So negative b plus 2a, what is a? That's 1. So this is 2 times 1. Negative 3 is equal to negative b over 2. Multiply both sides by 2. Negative 6 is equal to negative b. Don't confuse the 6's with the b's. 6 is equal to b. So that would be choice 2. And the rest you can do yourself. It's not that hard. Question 35 is similar to this, but just do it the way I just did it. And you should be set. Thanks for watching. Oh, you thought I'd lost this outro clip, did you? No, I've always saved it. So I'm bringing it back.